Hi guys, back with another supplementary installment of information for you on South and East Asia. India and China respectively have the two largest populations in the world. Both have some 1.3 billion people within their borders. So naturally, it's a good idea to discuss population and demography as you cover these two realms. When we talk about population geography, we're really looking at the spatial view of demography. We're looking at the population distribution, composition, rates of growth, and patterns of flow within an area. There are four demographic dimensions in South Asia. One is the role of density, another is the demographic transition models. Those are the two areas we'll focus on today. We will leave you to do some research on your own on age distributions and economics in these areas, and also the gender bias in birth rates. One area to really look at is population density. Population numbers like 1.3 billion people mean very little unless we understand how large of an area we're talking about. Now, there's two kinds of population density people usually cite. One, much more commonly cited, is arithmetic density. This is the average number of people per square mile. And in India, we're looking at 1,050 people per square mile. And in China, which is a much larger country, of course, even though we have the same number of people, we only have 531 people per square mile. Now, I know that doesn't mean a lot without some frame of reference, so let me give you something a little closer to home. Wyoming, by contrast, has a whole 6 people per square mile. Lawrence County, which is where Black Hills State University's campus is located, has 13 people per square mile. Still, even this doesn't give us a really accurate sense of density. So let's look at physiologic density. This is the number of people per unit of land that can produce food based on current technologies. That kind of land we call arable land. India only has 48.8% of the land considered arable. So the physiologic density here is 1,442 people per square mile. China is, of course, much larger. But because of the dry climates and the mountainous environments in much of the West, only 14.86% of China is considered arable. That's a considerably smaller amount. So here, there are 1,509 people per square mile in terms of physiologic density. So surprisingly, China is actually more dense than India. Now, if you talk about densities, this really naturally brings up a question of overpopulation. Did you think about the idea of being surrounded by 1,500 people per square mile and think, wow, the world is really getting overpopulated? Well, the idea of overpopulation isn't new. It's been conceived of for several hundred years in the West. In fact, Thomas Malthus was probably one of the more famous early proponents. He was an English clergyman at work in the late 18th century. And his work was particularly influential in economics and demography. Malthus analyzed the rate of population growth and the rate of the growth in the food supply, and he saw dire consequences. He predicted a point within his lifetime, or maybe the next generations, when wars would be fought over food resources and massive famines would sweep the world. He even went so far as to propose some really radical solutions to the problem, such as withholding major medical care from people, and relocating towns into swampy areas to introduce more disease into human populations. Oddly, Malthus's predictions didn't come to pass. Do you remember major famines that swept the entire world? Or wars that were fought over food supplies and resources? Well, why not? Let's talk about why they didn't come to pass in a moment. Because it turns out this idea of overpopulation has crept back into public consciousness again and again over time. Most recently, it crept back into the West again in the 1970s as the science of ecology came into being. Scientists began to discuss things like carrying capacity. Carrying capacity is something you're probably familiar with. If you need another definition again, it's the maximum population of a species that can reside in a given location. It's the idea that a species will increase in population while food is abundant, but as soon as it exceeds its resource limits, huge die-offs result. And it seems pretty reasonable to assume the same pattern for humanity. We are, after all, just another mammalian species. Paul Ehrlich wrote a book called The Population Bomb in the late 1960s that really brought the idea of overpopulation into public consciousness. It was full of alarmist predictions of mass starvation throughout the world by the end of the 1970s. But when that didn't come to pass, subsequent editions would promise the same dire scenarios within the next 10 years. But these didn't come to pass either. Does this sound familiar? If so, it's because it is. It's essentially a repeat of Thomas Malthus's predictions from the late 1700s, isn't it? So why didn't Malthus's and Ehrlich's predictions come to pass? Well, the carrying capacity model doesn't apply to humans in the same way it does to other species. We are qualitatively different. Our most important biological adaptation is our ability to think abstract thoughts. We have the ability to anticipate possible futures and to make changes to ensure they occur or do not occur. Our ability to think abstract thoughts greatly affects how we respond to and change our environment. Malthus failed to account for this ability to think abstract thoughts and make appropriate changes. He failed to account for the idea of birth control or the fact that people might willingly limit the number of children they had. He failed to account that as people moved into urban locales during the Industrial Revolution, family sizes would change and that birth rates would fall. He failed to account for changes in human technology, such as happened during the Green Revolution, when we had things like innovations in crop rotation and innovations in pesticides and fertilizers that greatly increased crop yields. You see, what Malthus actually predicted was an arithmetic level of growth in our food supply. But what we actually experienced was an exponential growth in our food supply. And Ehrlich, too, seems to get tripped up by these same sorts of mistakes.